Hi, good evening, everyone. So we'll just, I think, give it a couple of minutes to wait for more people to join in, and then we'll just start. Okay, I think it's time. Let's start. So good evening, everyone. Welcome to this SoPHE technical event. My name is Giovanni Tocco, and I'm the new SoPHE UAE chair. And today we have the pleasure to provide a technical presentation on SUDS and stormwater management in the Middle East, hosted by Polypipe. For those who don't know, CIBSE SoPHE responsibility as a region is to promote the intellectual welfare of its members and provide the understanding of building services engineering within our society by organizing events and other activities related to the built environment. The agenda for today is a quick introduction about the SoPHE UAE team, SoPHE UAE updates, and followed by the technical presentation, which is on SUDS and stormwater management in the Middle East by Polypipe. Then we're going to have the Q&A sessions and upcoming events. So as I said, my name is Giovanni Tocco. I am the public health engineer, chair of SoPHE, taking over from Keith Perry, who unfortunately moved back to the UK a couple of months before. And I'm a public health engineer. I've worked in different regions, and I've been in the Middle East for the last 7 years. The vice chair will be Adam Smith, who has been in the region for more than 10 years and is well known in the region. The SoPHE network consists basically, we are kind of a branch of SoPHE UK, and we have around 114 members in the region, which consists of different membership grades. Key objective, SoPHE key objective is mainly to facilitate knowledge sharing, provide seminar and technical events by promoting key challenges in the UAE region. And we have a big emphasis on aiming to provide upscale of public health engineers and safer building environment. SoPHE information. So what I will really encourage people to access SoPHE information with regards to membership, SoPHE journals, etc. So ideally, I will encourage people to just visit the CIBSE website, where we'll get all information on SoPHE. I will also encourage people to access the CIBSE LinkedIn webpage, where all the event will be posted online, upcoming events, and also all information with regards to SoPHE will be, you can get technical information on the LinkedIn webpage group as well. So today the technical presentation will be on SUDS and stormwater management in the Middle East, which is a very important subject with regards to stormwater, especially in this region, with all the challenges we are facing, especially with climate change and cloud seeding, especially, which is more and more frequent in the region. So the speaker today will be Adam Smith. And session notes, please tap your question in the Q&A panel. They will be answered by the speaker during the Q&A sessions. Your camera will be off and the mic will be mute. So on that note, I will hand over to Adam to carry on with the technical presentation.
Thank you, Giovanni. Just get my presentation up on the screen. Okay, good evening, everybody, or good evening to those that are joining us in the United Arab Emirates. So we'll take you through a short CPD presentation, as Giovanni's already covered the subject title. So thanks for joining, wherever you're joining from. So our agenda this evening, a quick slide on who we are for those that you don't know, but the main body of the topic really is to look at some of the stormwater challenges in the region, and also to proposition why we need to adapt. Some overview of strategy in terms of source control and particularly SUDS. And then what we've taken is a view from a geocellular solutions view for managing our future water. And then we'll talk to you why we specify your space. And then, as Giovanni said, we'll have some time at the end for Q&A. So just a health warning, obviously, firstly, this is a 50-minute superficial presentation that covers some very, very long topics. So we're not presenting as SUDS experts. There'll be many of you in the audience tonight that know a lot more about SUDS and practice than I do. But what we hope to do is to challenge the perspective of SUDS and give you some new ideas and challenge perhaps some of the myths about SUDS when applying it to sites in this region. So without further ado, a quick slide on who we are, and it will be quick. So we've been in this region for over 60 years. We've been helping clients and consultants deliver water and climate management on a variety of schemes throughout the years. We have an office in Dubai, and we have regional offices in Kuwait, and we used to be in Qatar. But we focus in two main sectors, one in the building, so water in, water out, drainage, and one in civils and infrastructure. So on with the main body of the presentation. So why we need to adapt. I think these are common facts that we will all know. But by 2050, it's estimated that 75% of the world's population will live in cities. And by 2025, half of the world's population could be living in water-stressed areas. So when we apply that to our region, Middle East and North Africa is home to 6% of the world's population. It has the highest per capita water consumption figures in the world, figures of up to 900 litres per person per day. And we've got 12 of the most water scarce countries in our region. So all the way back over probably between 130 and 190,000 years ago, the geology in the region was actually covered by lush, dense rainforest canopies, woodland, and Arabia, as it was known, was often watered by torrential monsoon rains. Just shy of 11,000 years ago, we've got into a desert scenario, and then just over 60 years, a rapid change, we've created a huge environment. So this presentation offers, the proposition of what do we do for the next 60 years. One of the drivers here is obviously the urban population increase. So these numbers were set in 2015 when the population in the region was just over 24 million. And by 2035, the forecasted population increase will be a 33% increase. So very rapid population increase across this region. So to house all those people, what do we create? We create these wonderful, usually coastal cities, big H-grid cities, hard, impervious areas, often look like that create a big sort of heat generator. And the difference between what we articulated this region used to be and some of those surfaces that we do create can be a difference of 50 degrees C or more. So when we apply that to our urban areas, the concrete absorbs the heat and creates what we call the urban heat island effect, where our urban areas are significantly warmer than surrounding rural areas. Microclimates are created due to dense construction and population. So concrete surfaces such as pavements and rooftops absorb heat like a giant storage heater, which gets released to us during the evenings and at night. Many of us who live here often sit out at night in the cooler temperatures, and it does feel warmer than the day. So some of the local water challenges, not too different to some other areas in the world. So do we have too much, too little? As Giovanni alluded to in the introduction, we're actually changing the weather patterns ourselves through cloud seeding, but clearly the climate has changed and also will change due to climate change. We've seen a huge increase in intensity and frequency of storm events. We have limited networks on already developed areas. We have seen significant local flooding. We've seen the duration of those storm events increase, and that's proved, in network stress and already increasing a very high water table, particularly in some areas of Dubai. So what do we do when we change the water and climate cycle? So we change the rate of water dispersion. So instantly we change the runoff when we create hard impervious surfaces. So from the natural environment to the built environment, we increase the runoff by about 45%. So we need systems that deal with the rate of water dispersion. The quality of the water released has changed, so pollutants that get caught up with that runoff, particularly from roads and traffic areas, needs dealing with, and the quantity of water released increases. So all this leads to quite some challenges for the designers when we mimic the natural drainage strategy. So this is the end product. There's some quite famous photos here. These are all in the public domain, I may add. You may recognise them. I'm not going to point them out by country, but certainly the one in the bottom right with the guy standing on his car, that was actually a year's rainfall in a day, and people getting stranded and caught out there in heavy traffic. And this was flooding back in the UAE. If you were in the UAE around 2016, March 9th saw the heaviest rain event since records began in 1977, where we experienced 287 mil of rain in a 24-hour period. That equates to a 1 in a 200-year storm event. So during the period of near continuous rain in March 2017, Dubai police reported 1,447 traffic accidents in just over 3 days as a result of the unstable weather conditions. So a huge impact when it does flood. So there is drivers for change. There is good news out there. So we are seeing a lot more of the government codes look at water recovery and reuse. The topic we'll cover is some of the SUDS strategies, or water sensitive urban design. We have new green building codes in the region. Some are very brand new, some have been around quite a long time. Particularly myself, who lived here, as I say, for 10 years, there's an increased social awareness of flooding, particularly as these countries in our region are now on the global stage with events such as Expo. Sustainability is coming to the fore. There's an environmental consciousness, and we are seeing the beginnings of legislative change to incorporate things like SUDS into design codes. We'd like to see more water conservation. We certainly professionally get involved with a lot of sites with zero discharge, with no networks planned or existing. And we'd like to see that incorporated into the engineered drainage systems, and also for the future, looking at specifications of how we deal with climate change. So the three main areas we focus on, I think the key area for us is the high density population areas. We'll say with that trend, people moving into the city, a lot of buildings, large footprints here, limited space for networks or connecting onto existing networks. It's a mixture of good water management with green infrastructure that must be the future, where we've got that integrated approach. So this is just a depiction of a typical catchment area. This is a school where we've got lots of green areas where rain falls on the roof. We've got systems that capture the storm event, normally piping systems here off the roof area, transported down either into storage and treatment, which can be reused. You'll see there it goes back into the toilet areas, or then it's out of the building plot, usually into the network or storage and attenuation, and back into the natural water course. So the first part of what we were talking about was SUDS. So SUDS, or sustainable drainage, is really a departure from the traditional approach to drain sites. There's 4 pillars. So control the quantity of runoff, the quality of runoff, create and sustain better places for people, and create and sustain better places for nature. The key principles of the strategy are attenuation, so storing runoff and releasing it slowly; source control, harvesting and using water close to where it falls; infiltration, allowing water to soak into the ground; conveyance, slowly transporting water on the surface; filtration, filtering out pollutants; and finally flow control, so allowing sediments to settle by controlling the flow of water. The picture on the right is the SUDS manual. This is a SUDS manual by Syria. We are seeing that in the region. Obviously, as a quick link, you can go on to Sustrain and access the SUDS manual. Many of you may already had it, but that gives you in detail the processes and strategies. I've picked out just the 20 or so benefits just to run through, but I'm not going to run through these in detail. Some of you may know these. But the big impact here is flood risk management, so using SUDS strategies to mitigate the flood risk; water quality, so removing pollutants at source, improving surface water quality, particularly if it's recharged into aquifers; biodiversity and ecology, so dealing with water close to the surface; amenity. Obviously, there's a direct ROI benefit to developers, particularly here, for an attractiveness and desirability of an area or usability of an area; air quality, an impact on health from air pollution; building temperature. Of all of our buildings here are cooled most of the year, so thermal comfort, providing insulation, particularly in the warmer months; carbon reduction and sequestration; crime, so using landscaping to prevent crime; economic growth, education, and certainly enabling development, and a few more; flexible infrastructure, so climate change adaptation. We are seeing a number of schemes being designed that include extra storage now for climate change, anywhere between 10-20% up to 50%, depending on the application. Groundwater recharge. I think it's a well-known fact that Abu Dhabi are consuming water from their aquifer at 20 times the rate that it can be replaced, so a real need to look at that there. Health and well-being, lots of studies about adding green or blue-green into infrastructure and buildings, particularly in hospitals, healthcare, schools, about the benefits to people, particularly physical and emotional and mental health benefits from creating these spaces. Rainwater harvesting, recreation, as we've mentioned, particularly for tourism and there. So I've put a link at the bottom of the page. Happy to share that with anybody. Some of you may know that site already. So that where we look at those 4 principles, just break those out. So biodiversity, particularly in this region, produces better spaces that sustain and support the diversity of the natural environment. I was talking a lot about health and well-being. We're seeing a lot of integration of green into buildings here. Water quantity and water quality we've already spoke about. So if we start looking at a specific water management strategies, so we split those into 3. So you've got at source, so a 1 in 5 year storm event, what we call source control. So to effectively manage stormwater runoff within the development as close to the source as possible. This provides a number of downstream benefits, particularly if you're attenuating or storing. The solution often includes pervious pavements or geocellular structures that are shallow, that collect stormwater and provide better land use, and rather than ponds or swales. Then a site-wide approach, which is a 1 in 10 year storm event. So the ability to treat, store and attenuate larger storm events, the effective management of stormwater not dealt with at source, multiple benefits derived from drainage systems that reduce flood risk, and then down to a 1 in 100 year, so regional control, so large scale regional control needed to ensure appropriate flood risk management strategies. So this is aligned to source control and site control that have a direct interface with nature for pools, ponds, swales, natural watercourses, and obviously control extreme storm events. So we look at a conventional drainage strategy. So water falls on the catchment area, that may be the roof area of the building, it may be a car park or a landscaped area. Traditional method is to capture that, collect it, and convey it away from that space as safely and conveniently as possible. Normally into storage here or soakaways. Bigger pipes, obviously the increase in volume of water, deeper pipes, which is a challenge here with the geology, perhaps high water tables, particularly on a lot of developments here. So if we look at an alternative strategy using source control, here you can see we're using all of the available space on the building roof area and podium deck area. So we're attenuating and flow controlling the storm event there. While you've got water very close to the surface, you can also look at reuse. That may not all just be storm water, but include other sources of water like condensate. And then we can see downstream, we've got a vastly reduced infrastructure scheme, a very little buried pipe, and then the end storage and irrigation is hugely reduced. So a different view. So just another depiction. So we've got treatment here. So we've got a green roof or a blue-green roof. We're using a cascade effect to come down the building on the left-hand side, over car parking, and then even over some underground car parking. And there are a variety of geocellular structures in the market that can be adapted to go under sports arenas that provide that SUDS element, which attenuate and retain water. So a more traditional approach, what we call a treatment train approach. Collection, obviously through gullies. So wherever you're collecting from, whichever catchment area. There are lots and lots of different treatment options, from very basic silt traps, which are preferred by a lot of the municipalities here, all the way to very high grade sand separation into the geocellular units. And there's a variety of units we'll talk about shortly. And then depending on what you want to do with the water, we can have controlled discharge through flow control, and then downstream filtration to class 1 separation. So there's a variety and a number of components we can install upstream and downstream that give you a management train approach. So an indicative application for infiltration could look something like this. You'll see on the left hand side of the screen, we're using the roof as first stage attenuation. So we're capturing in a geocellular structure under hard permeable paving and channels. We're using some of that water to include with the irrigation of a green roof. What that allows you to do is control the flow into your pre-filtration, away from the building, and then into a tank with access that allows the water to percolate away into the ground. And this is usually wrapped with a permeable geotextile. Detention is very similar. We're going through the same pattern from the roof, through the units, into the pre-filtration. The difference being here, we've got an outlet into a flow control. We're seeing this more and more in sites where clients are demanding that sites now adhere to pre-built runoff rates. So it's about slowing the water down rather than soaking it away. These tanks are wrapped in a geomembrane as well as a textile to create a tank. And then finally attenuation with an overflow, very similar. The difference is there's a pump unit fitted into the access, so you can reuse the water, traditionally to supplement irrigation here. There's a lot of green spaces and buildings, so it's slightly different. Again, I'll point you in the direction of a Syria, a guide. This is Syria C680. I'm sorry, that's just not shown on that graphic. So it's C680, which is the regulation and guidance produced by Syria for the design of modular geocellular tanks. That covers the whole span of the industry, testing, design methodology. For those that you don't have it, that will allow you to look at some of the applications that we mentioned previously. So now we want to try and look at how we interact with the water interacts with the ecosystem. So we've talked about stormwater runoff, we've talked about pollutants, we've talked about increased floods, increased urbanisation, and now the need to improve resilience and the use of blue-green infrastructure. So just a graphic depiction of what an urban area could look like in this region when blue-green solutions are integrated into the urban design. It delivers a number of multifunctional benefits. We get a significant air and water quality improvement. We get the pre-developed hydrology, habitat creation and protection, urban amenity, and one of the buzzwords clearly is well-being, health and well-being, areas that people want to be with families. So increasing tree cover and green spaces help combat the urban heat island effect, as we discussed earlier on in the presentation. And green roofs can help significantly reduce summer heat and the insulation, and also help reduce stormwater runoff. Some of those benefits, looking through the eyes from a geocellular perspective, where you can add them to roof and podium deck areas. So creating amenity, creating sports facilities, sports pitches, running tracks even on the roofs of buildings have been put in various cities in the world. Multifunctional spaces, so a mixture of hard SUDS and soft SUDS, where we can deal with the extreme storm events where you've got bioretention and swales, and then hard engineering SUDS to support that. We've got the blue-green roofs, obviously usable space, quite common here in the Middle East to find buildings wanting to use the space for recreation areas. Urban farming, very much connected with the circular economy and food production, where it goes back into the local community, particularly in schools. We've looked at a number of schools here, so a connection back to nature. It may not be food, it could be beehives, it could be natural habitat, so a direct link into the learning system, which includes all the biodiversity and the benefits that gives. So green roofs can retain up to 82% of annual rainfall, and the surfaces are up to 30 degrees C cooler. We often see a tie-up here between solar and green roofs. If you can reduce the temperature the solar panels are operating on, you can dramatically increase the efficiency of these units. And also urban trees. So the shading of 4 trees can save 20% of the energy needed for cooling a building. So some of the benefits of urban trees, yes, trees can now be part of your SUDS schemes. I'll show you shortly how. Studies have shown that living near trees and well landscaped grounds can improve health, happiness and well-being. There's a direct impact to ROI with green areas and tree areas, so they can increase the property values by up to 15%. There's some documented studies about apartments that look over green areas rather than grey areas, and people will pay more. The energy reduction in the building, so the cooling loads can be dramatically reduced with proper shading, natural shading, and obviously roadside planting and landscaping can reduce driver stress. So there's a number of benefits. So blue-green infrastructure. So when we look at climate change and the severe weather events that are becoming all too common in our urban areas and cities, we've got to think about the future. So source control, adding blue-green strategies in can help that first stage storm event to protect the infrastructure downstream. So an integrated approach that also helps human health. It provides urban cooling. It also can help with groundwater recharge, and working with some landscape consultants here, we've got some figures. When a palm tree dies, a live palm tree, it costs around 25,000 dirhams to remove it, rebole it and replace it with another palm tree. So there are a number of palm trees around here, so the direct impact to cost of prolonging the life of those plants and palm trees is a significant saving. So just to look at how geocellular systems work when they are shallow. So you'll see by the top graphic, a lot of systems can be installed under soft or hardscapes. Permeable surfaces can be used, or channel drainage to channel the water in. And a number of systems can offer what we call irrigation, natural irrigation. So there's no pumps. They use wicking textiles and cones to draw the water up out of the box into the growing media, and can propagate, say, green roofs, anything from a palm tree bowl at 2.5 meters depth to some grassed areas with 30 centimetres worth of depth. It's cyclical water management, so we're reducing the downward waste. They're integrated into the existing structures. They provide, when empty, insulation benefits. They are your first stage attenuation and flow control. They're shallow, easy to maintain and close to the surface, and can be economical if you take out irrigation and drainage elements from buildings. They offer building protection, so limited number of penetrations through the slab. I think we're all aware of certain buildings, if you live in Dubai, that flood in rain events. So the traditional drainage, taking that out, so all of the drainage is on the external of the building. And we can include treatment into those cellular units that offer the first stage treatment that can take fuel oils, hydrocarbons out. So it limits the use of very expensive equipment downstream. So say that one of the myths that always mystifies me is that SUDS isn't scalable, and SUDS is very scalable. Professionally, we've participated in single villas here, where we've operated with geocellular systems on roofs, podium decks, under grassed areas, and traditional piping systems. But any structural area really is available, and integrating it into, like say, your tree pits that can become part of your SUDS elements, or podium decks that have usable space. It has a direct correlation to property values, occupancy rates, and also buying decisions. So here we look at some of the sustainable elements. So very common here to use LEED as an assessment method. Obviously, a number of green codes introduced recently, but SUDS solutions that include blue-green strategies can score probably over or just up to 14 LEED points that are available, which equates to 25% required for certification. You get those for stormwater design, quality control, heat island effect, a reduction in water, so efficiency for landscaping, and innovative wastewater technologies. Say a lot of credits, 2 to 4 points there for water use reduction, and then an innovative design credit. And we must remember that, particularly here in the UAE, that water is one of the 7 pillars of the UAE's innovation strategy. So now I'd just like to talk to you about why specify your space. So once we've agreed the SUDS strategy and designed it in, we've used our systems that we think appropriate. Early engagement is really key. It's key with all stakeholders. Often SUDS schemes need a multidisciplinary approach. There's a lot of people involved, urban planners, landscape architects, even from early stages. Everything in isolation is expensive unless you can exploit some of the upstream and downstream benefits of including SUDS in your buildings and sites. Far too often or not, we see value engineering here that doesn't have much value and certainly doesn't have much engineering. But engaging with the right suppliers, manufacturers, we prefer to call it design development. So there's always work to do for us on site with contractors that allow us to have workable systems, but within keeping with the design and specifications. Appropriate material selection. We see in a lot of sustainability assessment forms about recyclable or recycled material, particularly where it comes to structural components. The material has a direct impact on structural strength. So there might be a conflict between your sustainable assessment and also the material that has a better structural component. So again, the manufacturing sector would know that. Peace of mind, and obviously good detailed design and technical specifications. And just a final point from me, I'd just like you to think that obviously we often say we can't specify our space here, or we can't directly do that. Other industries do it, and they do it because repeatability and safety, 100% is the minimum. And I quite like the airline industry example. Boeing's not quite a good example at the moment, but I'll use Airbus. And I don't know how many of us would feel if we jumped on a plane with our families and the pilot came over the tannoy and said, oh, we had an open vendor list for wings and engines and we don't quite know if they work, but we've selected them, but we're going to trial it during flight. I just wonder how many of us would actually stay on the plane. The suppliers are integrated into the Airbus factory and have long-term procurement agreements because safety is paramount. Those 550 people on an aeroplane shouldn't be treated to any differently than 550 people in a tower block. So we make decisions on safety all of the time, and industries that we use all of the time employ these tactics to ensure safety, health and well-being of the people who use their products. That concludes tonight's presentation. As I said, it was very superficial in the summary. Giovanni will look at any questions now and I'll try and answer them myself. I've included Lena, who's our Infra Division Director's contact details there. I would invite you, if this has been of interest and you have particular questions or schemes to talk about, we're happy to engage with you individually outside of this forum. Okay, Giovanni.
Yeah, thanks, Adam. Thank you very much. I mean, to cover the subject quite well. I would say as well is we have some additional issues in terms of drainage within the Middle East, especially with the couple of years Dubai has been growing, especially Dubai has been growing exponentially, and unfortunately the infrastructure is not as up to date, to be honest. So, and this kind of push lots of stress on the designers to make sure that when we're designing a building, we need to take care of SUDS and stormwater management, which is very, very critical to the region. Because as we know, basically all the engineers know here, the actual infrastructure is not really designed to take the actual flow rate or volume of water we're talking about. So that's very important. In terms of questions, yeah, we got a few questions. Somebody else, what is the difference between Manning and Hagen-Williams equation, and in which situation we may use it? I don't think that is a relevant question to the subject really. Yeah, again, there's different equation in terms of hydraulic calculation, etc. Manning is mainly to do with, you know, gutter sizing, stormwater sizing, channels, etc. I would say, but I think the question is not really relevant to this discussion.
I think we'd be happy to come and have that question. We could talk about sizing and hydraulic calculations, particularly when using geocellular structures. They're quite different, but obviously we'd happily come and address that individually.
Fair enough. We've got another question, which is what is the approach roughly to calculate the maximum amount of water that can be retained in a building roof for further controlled discharge, mindful of extra loads that this may produce in the structures of the building? Pros and cons. Yeah, so what are the pros and cons in terms of how much water we can retain on a particular building roof, etc.?
Yeah, I think from a generic point of view, you're not looking to hold the water on the roof for a long time. So there are minimal loads as such, but you do get that benefit back because you are creating a gap. So in terms of structural benefits, but every roof is different. Every catchment area is different. There isn't really a maximum in terms of load, but I think in terms of roof design here, and we'd have to be corrected that there are maximum loads you have to calculate. So we work with structural to make sure our systems are integrated, but I think I'd answer that by saying that every roof is slightly different. There is no maximum that we've come across. We've approached every job individually. We've got 20,000 meters squared on the Expo. We've got 700 meters squared on a 72-story building, totally different. But obviously, because we're dealing with a finite volume of water, we can provide finite values for how much water we believe will be in the cell, and those can be applied to the structural design of the roof.
That's good. We've got another question with regards to rainwater figures in terms of intensity and how you account for climate change within these figures.
I'm not the super technical guy on this, but I can probably answer that. We refer you back to the municipalities' rainfall intensity curves. We get supplied that. I think what I referred to as in climate change is a lot of designs, particularly in Europe now, that include a percentage extra of storage to cope with climate change over a design life, and that may be 20, 50 years, 100 years, depending on the application and the system. I'm not aware, particularly in the UAE, that the municipalities are requesting additional storage for climate change, but I think it's based on an individual basis and knowledge, but it's definitely something we would advocate. But I don't think there's a norm here yet for the region. I may be wrong, but that's kind of what we see.
Yeah, if I may expand a bit on that, Adam, again, especially in terms of UAE, Dubai perspective, I think people get a bit confused in terms of the actual rainfall intensity as per code, and in terms of the building design and the infrastructure design as well. Normally, if you read the code, the municipality advocate to use 1 into 5 years, 1 into 5 years, 90-minute duration, which equates to around 20 millimeter per hour. 20 millimeter per hour, which is very, very small, to be honest. But this figures is being used as an infrastructure design figure. But in terms of building safety, normally you still need to kind of take the building safety on board into consideration. And normally what I will really advocate is to consider a primary drainage and an emergency overflow secondary drainage as well, to make sure that your building is safe.
Yeah, we do a lot of that in siphonic rainwater design, where we have a secondary overflow. There is questions over the codes and how applicable that is, not just to today's rainfall events, where we're seeing not just an intensity increase, but double events. So day after day before the infrastructure has time to soak away. So things are changing, but again, I suppose it's the integrity of the data that we get supplied. But yeah, I agree with you, Giovanni. You're probably closer to that in terms of an authority level.
Yeah, I think the issue that we got in terms of design risk really is to do with most developer will just stick to the regulation. And for example, in terms of attenuation, most people will just advocate, especially the DM municipality will advocate for 1 into 5 years, 24 hours duration in terms of storage. But again, based on cloud seeding, we are getting huge rainfall intensity within couple of hours. And potentially if you have a attenuation tank within your basement, that's going to be flooded very quickly. And those are the issues that we are already facing in this region already. So I think this needs to be accounted when we're doing the design.
Yeah, I think once you've agreed what's appropriate with the client, obviously then we work on that data to provide an appropriate solution. Although we can advise, obviously it's the data that we get given that we can design to.
I've got a question from Mike from Hong Kong. I think in terms of Hong Kong design, mostly they used to collect the stormwater from the roof of the building for flushing, toilet flushing. Is it something popular in the Middle East?
I think in my view and my limited experience, culturally, it's not water reuse, particularly for washing, hasn't been preferred. I've not seen too many systems here, as within Europe and Hong Kong, that actually collect that water and use it for toilet flushing and grey applications. But Giovanni, you may have a different view in terms of the design.
Yeah, it depends on type of project really. Most of the cases, if it's kind of within a building, we don't really advocate for it as well in terms of rainfall, frequency of rainfall. So it rain like basically 3 or 4 days per year in the region. That's the issue. And when it rains, it's really as well. So I think it's to do with frequency of rainfall as compared to other part of the world really. So we don't really use rainwater harvesting, but mainly attenuation, just to make sure that we can manage the SUDS.
But it is a shame, Giovanni, because we do have an abundance of other water sources here. Obviously, all our buildings are cooled, and there's billions and billions of litres of condensate treated as a waste product and just put back into the drainage system here, rather than considered as a legitimate free source of water. And that can eliminate potable top-ups, certainly TSE for irrigation. So it's perhaps not just focusing in the Middle East on the storm event, but there are lots and lots of other sources of water here, which if we use differently, could also help us mitigate a lot of potable, or say TSE for irrigation, particularly on buildings and landscape roofs.
Good point. Yeah. Next question, I've got a question with regards to what about the maintenance aspect of SUDS systems. Can you elaborate a bit more on that in terms of maintenance costs, etc.?
I can certainly elaborate on our advice to everybody is prevention's better than the cure. Upstream filtration, don't rely on your end of pipe solutions to do all the work. Now that obviously in motion here, maintenance is a bit of a scary word. So when we provide proprietary sand traps or filtration, obviously we provide advice on maintenance, and particularly after storm events, when to clean them, a bit like cleaning roofs and roof outlets. Our advice with any of solutions that we provide, and I can't comment on others, is that we do a number of system upstream that's designed to be maintainable, because you don't want your end of pipe solutions getting clogged or blocked. And particularly with sand, 90% of it here can get dealt with upstream, but you are going to get some fines in the water, but they end up being quite porous. In the instance of geocellular tanks, even if they were to block the bottom of the tank, you still get the hydraulic flow outside the sides of the tank. So We have seen a number of designs that don't have any filtration on. Obviously, then whatever comes into your pipe goes into your tank. So that would be kind of our generic advice, but it depends on the water quality and quantity, depending on the device that you need.
Got another question. We are having solution for efficient urban design for sustainable drainage system. How about rural areas? As majority of the landscape in the world is rural, how better could storm water be catched?
I think if you just look at the traditional sort of water cycle we presented on one of the earlier slides, we've done some work here with date palms where we've used some of our systems to capture water and irrigate date palms better. You lose at least 40% here to evapotranspiration when you use over soil irrigation, particularly on sand that coagulates and acts like a concrete, so it actually looks runoff. So there's an immediate 40% saving. Obviously, depending on the quality of the water networks and leakages, you're always going to lose that before it gets to there, but that's more of a DEWA issue. We often walk around areas here and we see a lot of spray irrigation that isn't actually going on the grassed area. It's actually running off onto the pavement, and the paved areas are all damaged and the blockwork's damaged because of that over irrigation. So in terms of rural areas, we do look at particularly food production, under soil irrigation, tree, let's say date palms, quite common here, just to get the efficiency gains of the constant watering that they need. Does that answer the question?
Yeah, sorry. Yeah, I don't have any other question actually.
Yeah, I think obviously we tend to focus on high frequency developments where landscapes are integrated into the urban area, such as urban trees, where you have hardscaped areas. And we all know walking past footpaths where the roots of trees have damaged footpaths, particularly when I was a child walking to school. So we look at improving that, and I think that's where geocellular solutions come into their own, because you can store very large volumes of water in very small spaces rather than traditional aggregates or soil.
Got one more. What if we are to convince client of a new development to go for a SUDS system versus traditional stormwater tanks? What are the key points we would put forward to justify it? Is it more costly?
No, well, yeah. I suppose it depends if you can have that multidisciplinary approach. So, for instance, if you look at a podium deck on a hotel, you often have separate systems for drainage, catchment, irrigation, washdown. All that can be integrated into the structure and captured and reused. Then you've got the green benefits, the sort of propagation of green areas, which somewhere like a hotel people pay lots of money for. So there's a direct correlation to ROI. And actually, some of the systems that we've worked on here actually become cost negative, because you're taking a lot of traditional systems out of the design. It really works well when you can integrate landscaping with it, but we do a lot of conveyance systems here that don't have landscaping. You get the flexibility of choosing your outlet, so low penetrations, there's construction benefits. So often ceiling heights, particularly on car parks, are dictated to by gravity drainage. If you remove that element, there are huge construction benefits. And also what's probably there's less data on, but instead of blue-green roofs, they're now looking at carbon efficient roofs, where there's a lot of research going on at the moment. I think they call them yellow roofs. By creating that air gap, obviously you're providing an insulation element. And so we're trying to prove that there's a difference in the cooling load requirement and the energy use. So short answer to the question is most schemes can either be cost the same or cost negative, but it really depends on the application and where you can include upstream and downstream benefits into that cost reduction.
Good point. Any other questions? I think that's all I've got so far.
Shall I stop sharing, Giovanni? And
yes. Okay. Anyway, if there's any other question, you've got the contact details of Lina and Adam. So I would just encourage you guys to just drop them a quick email if you have any specific question that you require any answer. And yeah, we'll be happy to assist as well. Okay, so in terms of upcoming events, what we have, we're going to have an event with regards to domestic hot water balancing system and Legionnaire control by CIBSE. The tentative date will be around the 26th of November to be confirmed. So we're going to send an invitation as well when the event will be live. But that's a very important topic that we will look forward to for you guys to attend. And it's one of very important subject in the Middle East as well. And we are planning to have another event with regards to siphonic rainwater drainage system, which will be covered by Jaberit. And that will be around the second week of December. And again, we're going to confirm that in due time. Yeah, and closing event. So thank you very much for attending this event. Thank you very much, Adam. I think the surge one is a very important topic that we wanted to cover for a long time. In terms of any information with regards to upcoming events, technical information, please access the CIBSE website and the SoPHE website as well in terms of membership form. And if you have any additional questions, especially with membership, etc., please don't hesitate. Please contact myself or Adam, and we'll be happy to assist you guys. So thank you very much. So I think on this note, we'll close the event and looking forward for the next one. Thanks very much, everyone.